Algebra 1, Lesson 57, we are finding the least common multiple of variable expressions. Now first, the least common multiple, we call this the lowest quantity that is a multiple of two or more numbers or expressions. So for example, if we were looking at numbers like 3 and 4, well, we would say the least common multiple, we could look at the multiples like 3, 6, 9, 12, 15, 18, and so on, compared to 4, 8, 12, 16, 20, and so on, we would see that the one that they have in common, and the smallest one they have in common, is 12. So we would call that the least common multiple. Now we have a couple different ways to do this. So first of all, one way that we can find the least common multiple is writing each of the numbers as a product of prime factors, then use every factor of the given numbers as a factor of the least common multiple. Use each factor the greatest number of times it is a factor of any of the numbers or expressions, and I'll show you exactly what this means. So we're going to try it out on 24 and 36. So just like it says, we're going to write each of these as a product of its factors. So I'm going to take 24 and use our factor tree to split it up into 4 and 6, 2 and 2, 2 and 3. And we're going to split up 36 into 6 and 6, 2 and 3, 2 and 3. So we can say that 24 is 2 cubed times 3, and 36 is 2 squared times 3 squared. Well, in our prime factorization, what I'm going to do is I need to use a 2, since that is a factor that I have. I'm going to use a 3, since that's also a factor that I have. In this one, it's just a coincidence that both of them come up in both of the numbers. But what I really care about is how many of each that I want. Now, I have to use a 2 and a 3. For the 2's, I want to know, is 2 to the third, is that more 2's, or is 2 squared more 2's? And I would say, well, 2 to the third is more 2's. So I would use 2 to the third. And in comparison between 3 to the first and 3 squared, I'm going to use the squared because that comes up the greatest number of times. So in this case, I end up seeing that I'm going to multiply 8 times 9 and find that my least common multiple is 72. Now we have another way to do this, and it's called the birthday cake method. And we're going to take our numbers and divide by a prime number on the outside until we get a prime number on the inside that is no longer a factor of the other number inside the box. So I'm going to divide by 2 first and get 28 and 64. Divide by 2 again, get 14 and 32, but I still have to keep going because neither of them are prime. So divide by 2 again and get 7 and 16. Now 7 is a prime number and it's not a factor of 16, so I stop. And I'm going to use the factors on the outside and this last row of factors to find my least common multiple. So I'm going to multiply together 2 cubed times 7 times 16. And let's see, when I do that, multiplying together 8 times 7 times 16, I find that the least common multiple is 896. That is our least common multiple between 56 and 128. All right, another example of the birthday cake method, 8 and 12. So we divide by 2 and see that we have left, when we divide by 2 again, a 2 and a 3. So we stop and multiply together 2 times 2 times 2 times 3 to get a least common multiple of 24. All right, which would make sense for this to be our least common multiple because 24 is the smallest multiple that comes up for both of them. All right, so another example. I have put what we are going to divide by on the outside. So we get 18 and 27. Divide by 3 and we get 6 and 9. Divide by 3 again and we get 2 and 3 and we stop. And we're going to multiply together 2, 3, 3, 2, and 3. So we're going to get 2 squared times 3 cubed, or 4 times 27, which gives me 108. 108 is the least common multiple between 36 and 54. All right. Now going back to our prime factorization method, I'm going to try these three numbers that we have here. So 11, 12, and 18. I am going to say, I'm going to split these into their prime factorization, which for 11, it's a prime number, so we just get 11. For 12, I have to break that into 4 and 3, 2 and 2. So we have 2 squared times 3. We have 11, 2 squared times 3, and then 18 will break into 2 and 9, 3 and 3. So I have 2 times 3 squared, which means in my end least common multiple, I'm going to need to use an 11, because that's a factor that comes up, a 2, and a 3. I have to have all of the factors represented. Now I look to see how many of each I need. Well, there's just one 11. The 2 squared is the highest one, the biggest one, and the 3 squared is the highest one, which means I'm going to be multiplying together 11, 4, and 20. Oh, sorry, that should be a squared, so it should be 9, which means I am going to get 396. That is my least common multiple between 11, 12, and 18. All right, so you can try it on the last one. Just know that 7 and 13 are prime numbers, so we're going to have to multiply 7 and however many 2's we have, which in this case 2 to the third, and 13, and we get our least common multiple. Now, if we want the least common multiple of monomials, we're going to do something similar. We're going to break the numbers into their prime factorization, so 2 and 3 and 3 squared, and then we're going to look at our variables. Remember, we must have all of the factors present, so I need a 2, a 3, an x, a y, and a z present in my least common multiple. So I am going to use the biggest 2 that I have, the biggest 3, which is over here, 3 squared, the biggest x, which is x to the 4th, the biggest y, and the biggest z, which when multiplied together gives me 18 x to the 4th yz. Another one. We break it into 2 cubed x cubed and 2 squared times 5 times x to the 7th. And we're going to use the biggest 2, which is 2 to the 3rd, the biggest 5, and the biggest x, which when multiplied gives me 40x to the 7th. All right, so what's the least common multiple between these? Well, I will break it into 2 times 3 times p squared times s cubed. We have 2 times m squared times s squared, and we have 2 cubed times m cubed times p. So I'm going to need to represent a 2 and a 3, a p, an s, and an m. The question is how many? Well, the 2's, 2 cubed is my biggest one. For the 3's, 3 to the 1st is my biggest. For the p's, well, it looks like p squared is the biggest. S's, s cubed is the biggest, and m's, m cubed is the biggest, which means we multiply it out and we get 24 p squared s cubed m cubed. That is our least common multiple between those 3 monomials. Okay? And for this one, you should get 30 a cubed c to the 4th when you do the same process. Now, one last type of thing that we could see to find the least common multiple, and that is polynomials. So first, always factor, and then write any of our factors in prime numbers. And we want to include everything in the least common multiple. So we're going to look at this one first, the second one first. And we're going to factor everything possible, which means we're going to factor out a 7x, get 7x times x plus 3. We're going to factor out a 6 and get 6 times x plus 3, which means that we have 2 times 3. Now remember, all of these are factors. 7 is a factor, x is a factor, and x plus 3 is a factor. 2 is a factor, 3 is a factor, and x plus 3 is a factor. So I need to include a 7, an x, a 2, a 3, and an x plus 3. All right? And I actually need that amount. I don't have any more than that. So I multiply it all together, and we get, down here, 42x times x plus 3. Now, what if there's nothing to factor, like the 2 up at the top, 2m minus 3 and 5m plus 7? Well, in that case, both of them are factors, and we need to include both of them. So we say the least common multiple is 2m minus 3 times 5m plus 7. And you can multiply that out using your box method or rainbows and smiley faces or FOIL to find out what that is, or just leave it like this if they don't ask for it multiplied out. Okay, so one more example using factoring. In this case, we're going to factor out a 5p and have 3p minus 1 left over. Going to factor out an 8 and have 3p minus 1 left over. We need to get each of them into their prime factorization. This one doesn't change, but this one we're going to say 2 cubed times 3p minus 1, which means I need to include a 5, a 2, and 2 to the third is my biggest, a p, and a 3p minus 1, which means when I multiply it out, I'm going to be multiplying 5 times 8 times p, so we get 40p times 3p minus 1. That is my least common multiple. All right. What this leads us to do is something like this. A lot of times you'll see least common multiple problems like this. Every 24th backpack produced a green stripe. Every 60th, a big yellow dot. Every 36th, a blue diamond. How many backpacks will have been produced with until we get one with a green, a yellow, and a blue on it? And this is really just a least common multiple between 24, 60, and 36. All right, well, I hope this helps for your homework and for studying.